All right. So I ended up upgrading my computer's memory from 32 gigs of RAM to 64 gigabytes of RAM. I don't know if it's going to make any difference or anything since we weren't really doing anything intensive anyway. But I'm actually just really happy that now I have Ubuntu 24.04.1, which is the update I've been waiting for a while now because of stability. Yeah, let's just see how it works. I expect things to be more stable and maybe my computer will be faster. Not like I was like really slow to begin with or anything like that. So it's just cool to have 64 gigabytes of RAM. So, okay, yeah, let's see. Let's continue off where we left off with structs. I think we were at the midst of a long exercise. So it's just basically building off of our little fish program. It seems like we have additional structs here. So let's just read this entry word for word. The guys at the Head First Aquarium are starting to record lots of data about each of their fish guests. Here are their structs. So we have a struct exercise, which is a pointer description. So 8 bytes for the address to pointing somewhere in memory, right? Float duration. Okay, so that's like a 4 byte, the floating point number. Then we have a struct meal, so define as a meal type of structure. Again, a pointer to possibly a string in memory. Okay, and then a weight. Then we still have our same preferences and fish. But preferences changes to inner structs. So struct meal food. So variable name food that is a struct meal. So right here, remember we read these two things as a single type, right? So struct meal is like a single type. So it's the same thing as saying like double and then whatever or int whatever. So we read struct meal food. So meal is this one, and then we have another inner struct exercise. Call it exercise. So an exercise that is a struct this way. It's hard to explain. Okay, so let's write that down or type it. So we have struct exercise const character description. Then we'll have float duration. Then we'll have struct meal. Then we'll have const character ingredients. Then we'll have a float weight. Oh, we need semicolons after we define structs because they're statements. Okay. So remember, when we have a struct, they're kind of contiguous memory, just like arrays. They are, whenever we create a struct, all the properties of the struct are in contiguous memory, just like how elements in an array are. It's just that with an array, again, remember, we reference them by indices, and every single element is the same size because it's a single type. But with structs, you reference them by their property name, and also not all of them are the same size. Okay? So this is the data that will be recorded for one of the fish. So it looks like this. Name is Snappy, species Piranha, food ingredients meat. So ingredients is meat here. Food weight 0.2. Exercise description, swim in the jacuzzi. And then exercise duration 7.5 hours. So how would we write this data in C? Ooh, that's fun. Okay. So, I actually want to keep this. You know what? Let's create a new project and copy some of this over. So structs test shoe. C, and then we'll just do this. Okay, so we'll have that, and then we just get rid of this for now. And then we'll work off of this. Okay, and then maybe down here, we're going to kind of, yeah, we'll just get rid of all of it. Okay. All right. So we'll have a clean state. Should we have this one too? Complete the code and label function. Okay. So we had to complete code here. So I'm just cleaning up so that we can have something to work with. Okay. Okay, we're nice and clean now. I know it's kind of hard to see the code because we're falling off, but we'll do our best. So, first question is, how would we write this data in C? Well, I say it's structs fish because we're creating a fish. Snappy. Now, remember, for structs, we have to define all the properties in the same order as they're declared here in the struct definition. So, if name is snappy, that'll be the first element. Now, I'm going to break them up into different lines so it's easier to see. So, snappy will be our first property for name. Species will be piranha, again a string. Okay, how many teeth? Was there even teeth? Let's see. Teeth. I guess we could assume it's the same thing, 69 and 4 for teeth and age. So teeth here is going to be 69. Age will be 4. Now this is where it gets interesting. Care, preferences, care. Oh, we had to update preferences here too. Okay, so I forgot to do that. We had to update it to this. So we have to do struct meal food, which we have the struct defined here. Struct exercise. We have the struct defined up here. So that's cool. So our preferences struct has 2 inner structs. And then the struct preferences is actually, we happen to have one of these in our fish as an inner struct. So how do we create that? Since this is the last one here, we just define another struct that is going to be preferences type. So this will be going into here. We have meal, food, right? And that is a struct too. So we go up here, and now we have our properties. So since it's another struct, inside a struct, this will be, so we have the fish struct here, the preferences struct, and here's the meal struct. What's inside the meal struct? The ingredients will be meat, and then weight would be, what was the weight again? Let's see, 0.2. Okay, now at the next level of care, okay, now the next level of care is going to be, let's see, care, we had the food already, now we need the exercise. So the exercise, we have description and duration. So description of the exercise is swim in the jacuzzi. Exercise duration is 7.5 hours. So one more struct inside the care. A string swim in the jacuzzi. And then 7.5 hours. So remember, it's kind of hard to, like, when a struct gets this big, it's really hard to understand what property goes with what, right? So that's why it's important to put them all in the same order. But there is a way to kind of start naming them. I think we're gonna hit that soon, but for now, just try to kind of map everything back this way. Okay, so that's our struct. That's our fish struct. So to go over again slowly, we have a struct fish, which we're creating, where we have a name, Snappy, species, Piranha, teeth, 69, age, 4. Then we have a struct of a struct preferences called care, which is all of this here. Going into care, we have two more structs because care is a struct preferences type. So two more structs individually, right here and right here, which are meal and exercise, and then you can kind of figure it out from there. So just gotta go slow. So the next one is complete the code of the label function so it produces output like this. Okay, easy enough. So notice how we're expecting struct fish to be passed in, right? So it's easy. We don't have to have like so many parameters here. Like for example, name, species, teeth, age, meal, exercise, etc., etc. It's just one big container here that we're gonna get back. So we can actually start to write the print statements here by just tapping into the values like f dot name, f dot piranha, f dot species, and so on. So we'll do printf. We'll have name %s new line f dot name. So that's our name already. We'll printf again. This time it'll be species. %s new line f dot species. Then we'll print f again. We'll have 4 years old and 69 teeth. So we'll have an integer, years old, integer, teeth, teeth. New line. So it'll be f dot age, f dot teeth. Okay. Then we're gonna have something that says feed with %. I think it's 0.2f's because we want two significant digits here. Floating point, and then of %s. So the meat, food right here, meat, and allow to %s, which is going to be the exercise description for I think 0.2f hours for the exercise duration. So it's going to be a big one. So I'm going to split it into another line. And I should end my statement here. So, okay. Feed with f dot care dot food dot weight. Oh, I should put pounds. Pounds. Okay, so that's one. That's corresponding to this one here. The next one is f dot care dot food dot ingredients, which is going to be the string here. And then the next one is going to be the exercise. F dot care dot exercise dot description. And then finally f dot care dot exercise dot duration. Okay, so that's our label function. If we expand this out here, okay. Yeah, I think that looks right. 1, 2, 3, 4. 1, 2, 3, 4. Cool. So if we wanted to output something, oh, look, it's already giving us an answer, but we'll do it our way. Okay, so let's do this. This is the solution, and let's print this out. Let's print our label. So how do we do that? We'll call the function label with our snappy struct as an argument because it's expecting, what is our label expecting? A struct fish type. So we'll call it with snappy. Okay. And remember, when we pass in without pointers like this, I just want to, give you a preview. This is not we're not passing a pointer, we're passing a structure, even though it's like an object in other languages. This is a structure. It's going to copy the entire struct. It's going to take all of this, right, and make a copy and pass it into that function. So just make sure we're clear on that for now. Okay, so is it projects? I forgot where I'm at. CD code, average def, projects, and where am I at here? CDC, oops, CDC, where am I at? CD structs test2, GCC main.c, main.out. Okay, so we got this output here. Name, Snappy, species Piranha, 4 years old, 69 teeth, feet with 0.20 pounds of meat, and allowed to swim in the jacuzzi for 7.50 hours. So it's exactly what we're expecting. Solution. See how basically theirs is more condensed, but that's how we put inner structs, right? We just do it recursively, kind of like nested. So cool. Anyway, all these struct commands seems kind of wordy. I have to use the struct keyword when I define a struct, and then I have to use it again when I define a variable. I wonder if there's some way of simplifying this. So what they're saying is that, okay, well, when I define a struct, I always have to say struct meal, struct preferences, struct fish, and then when you want to create a struct of that type, you still have to go and say struct fish. That's like really wordy. Like, we already know this is a struct fish. Why do we have to say struct fish again? Can we actually really give it like a type? Let's see. So you can give your struct a proper name using typedef. When you create a variable for built-in data types, you can use simple short names like int or double. But so far, every time you've created a variable containing a struct, you've had to include the struct keyword. Struct cell phone, int cell number, const character, wallpaper, float minutes of charge. It's like a cell phone, right? Then when you want to create a struct cell phone variable or like a structure, right? You have to like say it again, struct cell phone, and then give it the label, the variable name, and then finally the data. Okay, that's inconvenient. That's kind of wordy. So C allows us to create an alias for any struct that you create. If you add the word typedef before the struct keyword and a type name after the closing brace, you can call the new type whatever you want. So then you could do typedef struct cell phone, and then give all the properties, and then the alias of how you want to use it whenever you want to create a struct of this type here. So in this case, how you would use it, since you aliased it as phone using typedef here in the beginning, so it's like, I want to give, so typedef is like saying, okay, typedef, all right, I'm going to alias all of this for this, okay? So it's basically two parameters into this typedef. Typedef, the definition of the struct, and then the alias you want it to be. So then it becomes, when you create a struct as a phone type, it's just phone P. Okay? Now, normally what I do is I just keep these names the same. I just alias it the same as the declaration like this. So I would have done typedef struct cell phone, and then cell phone here the same way as this, just to not be as confused. So then that's what this discussion is about. It's like this. What should I call my new type? If you use typedef to create an alias for a struct, you will need to decide what your alias will be. The alias is just the name of your type. That means there are two names to think about. The name of the struct cell phone, and the type, which is phone. Why have two names? You usually don't need both. The compiler is quite happy for you to skip the struct name like this. So you could do it like this too, which is fine. Okay? Yeah, so typedefs can shorten your code and make it easier to read. Let's see what your code will look like if you start to add typedefs to it. Okay, so let's do that. Let's refactor. So instead of just saying struct exercise, Let's do typedef structs, and let's alias it as exercise. Okay. Same thing for this one, meal. Oops. Same thing for meal. Typedef struct meal, and then let's alias it as meal. And then let's do typedef. Why does it do that? Oh, it's because I stopped. My eye is not registering. Typedef struct preferences. Then we'll do preferences here. And then finally typedef struct fish. And also give it an alias here for fish. Oops, fight. Fish. Okay. So we've aliased it all. That means we don't need to say struct fish and struct fish and struct fish anymore. Let me just get rid of this since we're not using it. Okay, so now we don't have to say struct fish. We can just say fish. Same thing down here. Just say fish because we've defined our own data type. This is our own data type. We can create many fish by just saying fish Snappy, fish Bob, fish Karen, fish Sally, fish Harry, and so on. Okay, so this is a scuba diver one. So we can do this one together. Let's see. Okay, let's do this interactively. I like it when we do that. I don't know how to take a screenshot. Okay, screenshot. Okay, let's paste that in the ScalaDraw. Okay, and then let's just do this. Let's move this here. Let's resize. It's a whole process. Okay, now I got my pen with me with my favorite blue color. Okay, so it's time for the scuba diver to make his daily rounds of the tanks. And he needs a new label on his suit. The trouble is, it looks like some of the code has gone missing. Can you work out what the missing words are? Yes, so here this one has to be. Why is it so laggy? Type. Maybe it wasn't a good idea to update. Typedef. Typedef struct. And then this will be what? Let's see here. Equipment. It looks like it'll be called equipment. So equipment. Wow. Let me just turn it off and turn it on again. This happens. Wow. Okay, maybe this time it'll work. Great, hopefully. Let's see. Ah, it feels better. Yes, it does feel better. Equipment is here. And this one will be typedef again. Typedef struct scuba. So then this will be scuba D, I guess, badge. So, okay, first let's do this. You're creating a scuba, Randy, and then you want to pass in Randy in, which is a scuba type. Okay, so that's scuba. So scuba, typedef equipment, and typedef. Something like that. Okay, so let's look at the solution. Yeah, typedef, equipment, typedef. Oh, diver. Oops. I missed it. Because I'm so used to Okay, I'm so used to always saying this to be the same, right? That I completely missed that. So this will be diver, and that's why there's diver D. Okay, again, it's weird. Okay. It's affecting my writing. Okay, so diver. Because we typedef alias to be diver. Darn, got tricked. Okay. Anyway, let's see if our program works because we typedef everything here so that now we can just call it fish. It should work the same way, right? Yeah, it works the same way. so that now we can create many fish without saying typedef struct, or no, it's not typedef, without saying struct fish. Too many typedefs. Okay. Okay, so let's review. A struct is a data type made from a sequence of other types. Structs are fixed length. Yep. Struct fields are accessed by name using the struct.fieldName syntax, also known as dot notation. Struct fields are stored in memory in the same order they appear in the code. You can nest structs, and typedef creates an alias for a data type. If you use typedef with a struct, then you can skip giving the struct a name. So what they mean is we actually don't need this. We actually can write structs this way right here. Same way. Okay? So do struct fields get placed next to each other in memory? Sometimes there are small gaps in between the fields. Haven't really seen that yet, but yeah, they're still contiguous in my eyes. Why is that? The computer likes to fit data inside word boundaries. So if a computer uses 32-bit words, it won't want a short, say, to be split over 32-bit boundary. Oh, okay. No. Okay, I read this wrong. All right. Yes, there are small gaps between the fields, but then there will be gaps. It will just still be used for the struct in this case. So if you have like a data type that doesn't fit exactly like 4 bytes, 8 bytes, 2 bytes, whatever, and so on, then yeah, your computer's going to want to create like artificial gaps to just give that contiguous chunk of memory. So does that mean each field takes up a whole word? No, the computer leaves gaps only to prevent fields from splitting across word boundaries. If it can fit several fields into a single word, it will. So why does the computer care so much about word boundaries? Meaning like sets of 4 or 8, depending on your computer. If you have a 32-bit computer, it will always want to kind of find like a convenient multiple of 4 to just like kind of put data in. And then if it can't, it's going to like kind of skip over a little bit, wasting that space right there. But that chunk is still most likely going to be allocated for that struct. So your computer will read complete words again, either 4 or 8 bytes, depending on your computer, from memory. If the field was split across more than one word, the CPU would have to read several locations and somehow stitch the value together. And that'd be slow? Yes, that'd be slow. In languages like Java, if I assign an object to a variable, it doesn't copy the object, it just copies a reference. Why is it different in C? In C, all assignments copy data. If you want to copy a reference to a piece of data, you should assign a pointer. I'm really confused about struct names. What's the struct name and what's the alias? That's a fair thing. The struct name is the word that follows the struct keyword. If you write struct Peter Parker, blah, 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 then the name is Peter Parker. And when you create variables, you would say struct Peter Parker X. And the alias? Sometimes you don't want to keep using the struct keyword. Okay? When you declare variables, so typedef allows you to create single word alias. Create a single word alias. In typedef struct Peter Parker, yada yada yada, Spider-Man as the alias, Spider-Man is the alias. Okay? So what's an anonymous struct? It's one without a name. So typedef struct blah with Spider-Man, okay, has an alias of Spider-Man, but no name. So most of the time, if you create an alias, you don't need a name. Sure. There's actually caveats to this later down the line, so I think that's why they kind of keep reiterating this. But we'll cross that bridge when we get there, I think. Okay. So how do you update a struct? So a struct is really just a bundle of variables grouped together and treated like a single piece of data. You've already seen how to create a struct object and how to access its values using dot notation. But how do you change the value of a struct that already exists? Well, you can't change the fields just like, well, you can change the fields like just any other variable. So it's just reassigning. It's just accessing the field and then reassigning that to a value. Simple enough. Okay, that means if you look at this piece of code, you should be able to work out what it does, right? Okay, let's see. Let's see. So we have a turtle struct here that has a name. It's a species of some sort and age. Okay, and then let's see. We have a function happy birthday that takes in a turtle struct. We increment the age, then we say happy birthday, you are now blah years old with the name of the turtle and the age. Okay, I see where this is going. Oh, okay, let's be careful. Okay, let's be careful. Okay, so this happy birthday increments the age of the struct and prints it out. Okay, now in our main function, we create a turtle, right? So a Myrtle variable that is a turtle struct with these values. Name being Myrtle, species being leatherback sea turtle, age being 99. We then call happy birthday with Myrtle passed in as an argument to the function. With that data, we access the age field incremented by 1, taking it from 99 to 100. Okay, then we print happy birthday %s, meaning the name of the turtle, which is Myrtle. So happy birthday, Myrtle. You are now 100 years old. Okay, then we return from the function, print again. Okay, Myrtle's age now is, what is it? Myrtle.age. What is it? Is it 100 or is it 99? So I say that we're going to get 99 because whenever we pass any value that's not a pointer to a function, it's just a copy. So happy birthday is actually receiving a copy of the Myrtle data and is just incrementing that copy and printing the information in that copy. When the function returns, that copy disappears because it's used already. Now we're back at our main function. Well, this Myrtle struct wasn't really changed because we had initially passed in a copy to it. It's automatically copied when we call the function. So yeah, it's exactly what we thought it'd be, right? So Myrtle's age is actually 99. WTF. Wicked turtle feet. So why? Why is that? I think I mentioned it, but let's see what they say. So something weird has happened. The code creates a new struct and then passes it to a function that was supposed to increase the value of one of the fields by 1. And that's exactly what the code did, at least for a while. Inside the happy birthday function, the age field was updated, and you know that it worked because the printf function displayed the new increased age value. But that's when the weird thing happened. Even though the age was updated by the function, when the code returned to the main function, the age never seemed to reset itself. The code is doing something weird, but you've already been given enough information to tell you exactly what happened. Can you work out what it is? So yeah, it's just the copy by value thing with the function calls. The code is cloning the turtle. Yes. So let's take a closer look at the code that called the happy birthday function. Okay, so void happy birthday, turtle t, and then we called it with Myrtle. Okay, so when you assign a struct, its values got copied to the new struct. In C, parameters are passed to functions by value. That means when you call a function, the values you pass into it are assigned to the parameters. So in this code, it's almost as if you had written something like this. Turtle t equals Myrtle, meaning that you're going to create a copy of Myrtle and assign it to t. Similar to how you would assign any other int value, double value to another int or to another double, for instance, that copies it. We're not, again, even though this looks like objects, right? So you would think coming from Python or JavaScript or Java, you're passing by reference. You're not. You're copying everything. But remember, when you assign structs in C, the values are copied. When you call the function, the parameter t will contain a copy of the Myrtle struct. It's as if the function has a clone of the original turtle. So the code inside the function does update the age of the turtle, but it's a different turtle. So this one. So what happens when the function returns? The t parameter disappears, and the rest of the code in main uses the Myrtle struct. But the value of the Myrtle was never changed by the code. It was always a completely separate piece of data. Okay, so we've always been operating that copy inside the happy birthday function. So the question is now is, what do you do if you want to pass a struct to a function that needs to update it? So we want to update Myrtle now. So how do we do that inside that function? How would we actually update all values without returning? Same thing like all ints, right? Or all what do you call it? All doubles, all longs, all primitive values. We just expect the pointer instead, and we'll just update the value pointed by that pointer. So we'll just, I'm guessing instead of, let's make another project. Okay, we'll create main.c, then we'll do include stdio.h in main. Let's stay disciplined. Okay. Okay. So let's stay disciplined. Let's type out all this. I should have done it earlier. Okay. So it'll be quick. Typedef struct. Then we'll have turtle. Okay. Then we'll have const character star name, const character star species. Then we'll have int age. Then we'll have a void happy birthday, turtle t, t.age plus t.age plus 1, printf, happy birthday %s, you are now %i, here's old. Okay, then we'll have, real quick, oh, I hate these pop-ups. Okay. For now, t.name, then t.age. Okay, and then we're going to create a turtle, Myrtle, turtle, Myrtle, Myrtle, leatherback sea turtle, 99 years old, and then we do happy underscore birthday, Myrtle. Then we're gonna say printf %s's %s's age is now %i, new line, Myrtle dot name, Myrtle dot age. Okay, let's see if we can get something similar. Okay, yeah, now 100 years old, now it's 99. So how would we modify this, right? How would we modify our code so that we can update, in this case, Myrtle's age inside the happy birthday, and then have it stick? Have it stick when it comes outside. How do we modify the real value? Well, again, I mean, if we want to if we want to actually modify the real thing, we can just pass a pointer and we can dereference all the values and update them that way, pointer style. Okay? So if we're passing a pointer now, we have to actually pass in what? The address of Myrtle. Okay? Just like any other value. The address of Myrtle is going to return us back what? A pointer to a turtle. Okay? That gives us back a pointer to a turtle. Okay? Because the ampersand is an operator that gets us back a pointer for any value. And this pointer can then be used in any function that expects a pointer of that type. In this case, a pointer to a turtle. Now, going back to our skills in terms of pointer manipulation, how would we actually update age now for this t? Remember left hand, right hand dereferencing things, right? So we could do star t, in this case, star t. But if you look at it, it's unknown, right? It's hard to actually figure out what's going on. Do I dereference all of this? Dereference all of this? Or do I just dereference this? It's hard, right? Do I just dereference t or do I dereference t.h? What do you mean here? So the compiler is still confused. So we want to dereference, in this case, t, I think. Let's see, there's a struct unit type. It has turtle star. Yeah. Is that what it is? Or is it this? No. I think it's this. Yeah. So we want to dereference that and then dereference this, dereference this, and then we'll get what we want. We should. Brandon has a struct unit type, but it has a type turtle star. I don't get it. It should work. I think. Oops. Let's see. Okay, let's look at the answer. Well, you need a pointer to a struct. Okay, so we got that far. When you pass a variable to the scanf function, you couldn't pass the variable itself to scanf. You had to pass a pointer. Why did you do that? Because if you tell the scanf function where the variable lives in memory, then the function will be able to update the data stored at that place in memory, which means it can update the variable. Okay, so that's what we did right here. Like we want to update it, right? We want to update it, but now we're running into this situation where we don't know how to actually dereference properly because of all these things here, these field accesses, which is probably throwing me off. So okay, let's read this. If you want to you could do the same thing with structs. If you want a function to update a struct variable, you can't just pass the struct as a parameter because that will simply send a copy of the data to the function. Instead, you can pass the address of the struct. Okay, we did that. Now, what do we do? Well, don't forget, t is now a pointer variable. Okay, so again, I would say star t, star t, star t, star t, because that's dereferencing it. It's a pointer value, right? Because this is a pointer now. So we did t, right? That's just accessing the pointer, but we want to dereference the pointer to get the value and update it. Look. Oh, silly mistake. I want to dereference t first. Order operations, of course. Yes. It's this way. I didn't see it. That's what happens when I'm programming by myself. So, yeah, this is what I actually meant. Like, so you want to wrap the dereference on the pointer itself before you actually access the field. Okay? So this is what I actually meant to do. I was actually kind of tripping up as to why that wasn't working. But that's like showing that I'm still learning C, right? I'm still learning too. I'm just like slightly ahead because I need to pre-read at least so that I'm at least entirely not clueless, and it wouldn't be productive. These videos would be like 3 times as long if you just see me just like sit around trying to um, muddle through. So this is, yeah, this is correct, right? We're getting a pointer, and then we want to dereference that and update it, right? We want to update the age inside this pointer, and then we also want to print out by dereferencing the name. I guess no, we want to dereference turtle. Then we want to take that value we get back, right, by dereferencing it and then accessing the name field. Same thing with age. So when we do that, we're actually modifying whatever we're passing in place. So we don't need to return anything, and therefore we should actually have Myrtle modified. So let's see that. Is this structs tester? Yeah. So GCC main.c, a.out. So yeah, so we have happy birthday Myrtle. You are now 100 years old. Myrtle's age is now 100. It's cool, right? So this is like any other value, right? It's just that it's trickier because of this. And that sucks. I'm going to forget again. Why can't I even forget, right? Because there's actually another way to do this that's much easier. And here we go. Dereferencing t.age versus, I guess, dereferencing t.age? So why do you need to make sure that star t, dereference t, was wrapped in parentheses? Because the two expressions, dereferencing t.age and dereferencing t.age, are very different. So one is with the parentheses. I'm doing this on purpose because it is confusing. I am the age of the turtle pointed by t. Okay, that's how we read it. I am, so accessing the age of the turtle pointed by t. And then this one is saying, I am the contents of the memory location given by t.age. Okay, so we have to access. This is like a pointer itself. This whole thing is saying that this entire thing is a pointer and you want to dereference it. Okay, and that's wrong because age is not a pointer. Okay, so the expression star t.age is really the same as star t, entire, right, wrap. So without the parentheses here, it's the same as wrapping the entire thing here, treating it as a pointer, which is not. Age is a integer. Okay, so you're dereferencing that, which is wrong. It's gonna crash, I think. So think about that expression for a moment. It means the contents of the memory location given by t.age, but t.age isn't a memory location. It's an integer, not a pointer. But the t itself is a pointer, so we can dereference it, but we have to make sure we dereference it alone. Okay, that makes sense. So be careful with your parentheses when using structs. Parentheses really matter. Test drive. So yeah, we did get it working. That's great. So that's great. The function now works. By passing a pointer to the struct, you allowed the function to update the original data rather than taking a local copy. Cool. So, yeah, I can see how the new code works, but the stuff about the parentheses and the star notation doesn't make the code all that readable. I wonder if there's another way that we can do this. Yes, there is another struct pointer notation that is more readable. Because you need to be careful to use parentheses in the right way when you're dealing with pointers, the inventors of C language came with a simpler and easier to read piece of syntax. These two expressions do the same thing. So this now is equivalent to just this here. Okay, so t arrow age. T arrow age is the same thing as saying wrapping star the reference of t with parentheses. So this will just directly translate to this, which is good. That's easier. So t arrow age, t point to age, means that the age field in the struct that t points to. That means you can also write the function like this. So let's change it. So it will just be T, age, T, age, T, name, T, age. So it'll just be like this. And that's way cleaner. Test it. Cool. So yeah, that's how we actually, if a struct is a pointer, right, we can access the fields easily without having to dereference it using parentheses and star asterisk. We can just dereference it using the pointer name with arrow and then the field name you want. So that's cool. That's cool. All right. Okay, safecracker. All right. It's late at night in the bank vault. Can you spin the correct combination to crack the safe? Study these pieces of code and then see if you can find the correct combination that will allow you to get to the goal. Be careful. There's a swag type and swag field. Huh? Swag type here, which is typedef struct, and then the field swag, which is a pointer. It's a pointer to this type of struct. So we're gonna hint. It's like we had to use the arrows, right? So let's see. And we have a safe that has a combination struct, which is this one right here with numbers. So that's another another complication is that this struct is here is not a pointer at all. So hint, we don't use arrows. We use dot for this one. Okay. And then the make, which is a pointer to a string. Okay, so remember, let's just be very careful. This is a pointer to a swag struct. This is literally the value of a struct. Okay, big difference. Okay, let's just be careful. Okay, so we have swag gold. So gold is going to be swag up here. So description gold, and value is whatever this is. Then we're going to have combination numbers. So combination is a struct, numbers is a label. With first, again, combination has what? A pointer to swag. So we had to get the address of swag because swag gold is just a value. So we had to get the pointer to go to assign it to swag. And then the string, the sequence. So 6502 is the sequence, maybe the combination. And then we create a S variable that is a struct safe type, which is right here. Then we pass in, I guess, the combination number struct right here, but not as an address, but as a value because it's taking it as a value. Then we have the make, which is just a string. Okay. So what combination will get us to string goal? So I think it's going to be, in this case, we want to get to gold. We want to get to here. The string here. This one right here. So it'll be S. And then numbers is what? Numbers is a value. So it's going to be dot numbers. Okay. Now in numbers, we know that swag is the gold, right? But it's an address. It's a pointer. Okay. So it'll be what is it? It'll be dot swag, right? Dot swag, and that's a pointer. Right here we're at a pointer. Then we're going to use that to dereference using this arrow. Description. Is it description? Yeah. Okay. So it's going to be S dot numbers dot swag arrow description. Let's see. Yes, S dot numbers dot swag arrow description. Great, cool. We got that one right. But let's read this. Okay, there are no dumb questions. Why are the values copied to parameter variables? The computer will pass values to a function by assigning values to the function parameters, and all assignments copy values. So why isn't star th just read as this one here with the parentheses all around t and because the computer evaluates a dot operator before it evaluates a star. So yeah, this has precedence. This is higher precedence. Okay, cool. All right, bullet points. When you call a function, the values are copied to the parameter values. You can create pointers to structs just like any other type. Pointer arrow field is the same thing as dereferencing pointer, wrapping around parentheses, and then finally accessing the field with a dot notation. Okay, the arrow notation cuts down on the parentheses and makes the code more readable. Okay, cool. All right, let's see how much. Okay, no, this is a different part. Okay, cool. This is a good stopping point. Let's get commit. More structs. Okay. Yeah, let's just stop because I think this is gonna go into a different topic. Unions. So I'll see you all next time. Bye.